So I'll kick things off. This is a part one webinar. We're going to do two parts in the spring semester. The webinar is about research computing services available at UMaine to UMaine faculty. It's being presented by Advanced Research Computing, which is a unit within the Office of the Vice President of Research and the Dean of the Graduate School at UMaine. So we're going to have three parts to the webinar today, followed by Q&A, and we're going to try to go through the slides efficiently to make sure that there's open time for any questions, any dialogue with attendees. I'll start things today with an overview of Advanced Research Computing. And Kevin Wentworth, who's a manager of research information management systems at UMaine, will highlight the Ohio supercomputer, their user environment, and do a bit of a live demo. And third, we have Ben King, who's a bioinformatics faculty member here at UMaine. We'll talk about his research computing experience at UMaine, as well as his experience with Advanced Research Computing. So I'll go back to the beginning. We launched ARC back in 2019, and it was really initiated by the Vice President of Research to help to improve access of world-class facilities, research computing facilities for the UMaine faculty community. So we did that in response to, after hearing faculty input, and even though we've been in motion now for more than 18 months, I'd still describe us as early in our life. And we very much like hearing from faculty across UMaine and other campuses and understanding truly what the needs are. And our role is to solve bottlenecks. This slide shows that we're focused on the customer experience. That's a very broad statement, but literally, every lab, every PI has unique needs and requirements. We work to understand what those needs are, where are the bottlenecks. If we don't have services already available in our portfolio to address bottlenecks, then our task switches to finding new services or new solutions. So this picture highlights what advanced research computing is and where we sit. And literally we sit between the user community and the research computing ecosystem, which is a fancy word that basically is all inclusive of any entity providing research computing services nationally. So we work with federal sponsors. There are national supercomputer centers we're engaged with. And of course, there's local partners, and the whole community is important to us. ARC itself sits within the UMaine core entities. That's a very important point, meaning any service that we recommend, the PI has an assurance that it will be compliant with OMB and UG Service Center compliance and policies and regulations. And this slide just emphasizes the importance of that. An academic institution not in compliance with OMB Service Center guidelines policies can be subject to federal fine, and these fines can be quite large in some instances. So we really focus on this. We benefit by sitting within the ARC umbrella, or excuse me, the core umbrella, and core itself has financial managers and support staff that really understand these policies and guidelines. So me and my colleagues don't have to be experts in these policies and guidelines because we're working with those that do. And any service that we put forward, it's scrutinized by that group, and they help us define pricing policies that inherently keep the PI safe. So we're still relatively new and things are still changing fairly rapidly. And I'm highlighting a policy that just came out at UMaine about a week ago. And you can find this at the Office of Research Administration website under the Guidance and Policy tab. It's all alphabetized. It's a long list, but because it's alphabetized and we start with an A, we're up at the top left. So this policy is pretty simple. I consider it benign, but it's helpful. And literally it's asking UMaine faculty members who are either contracting computational services or developing a new proposal to please simply reach out to Advanced Research Computing And we'll help you by understanding what your needs are, and we'll clarify if there are services available through ARC that can help with your scope of work. And if we don't have services that can help within your scope of work, we'll be honest about that. We are willing to search out new services if there's a need for, that direction. So this is live now, and it simply encourages communication. It doesn't really mean anything more than that. So please don't look at it as overly draconian. That wasn't the intent. So I'd like to take a minute. We've been around for about 18 months, but we did have a pretty active year in 2020. And this just highlights a few of the accomplishments or progress that we made in the last year. The top of the slide is very important. We launched a couple of premier partnerships with supercomputer centers. The second bullet's also very important. When in our first few months of existence, talking to different labs, we realized that there are many labs and research teams at the UMaine campus that don't really have their data reliably stored and backed up. And it was such a grave problem, we tried to elevate this. And I'll come back and talk about more of the details, but there is a new service that can help you if you're in that category. We launched a faculty advisory board, and Ben King with us today is one of the representatives of that board. And we successfully supported the current Track 1 grant being led by UMaine in the state of Maine. There was a lot of work done, and we won't have time to talk about all of that work today, but Ben will highlight a small piece of it. The bottom is one of the reasons we're doing the webinar today. Awareness and outreach is always important. We're in a large academic community, and communications are always a challenge. So things like this webinar being recorded, we'll put it on our website, and hopefully it'll help get the word out. We're also issuing a periodic newsletter. We try to issue about one every other month, and we put news updates on our ARC webpage as well. So I'm just going to step through each one of those bullets from the previous slide and go into a little bit of more depth. So cloud-based services, this is a term that I think everyone in the US has probably heard a lot of in the last decade. And cloud-based services can, it's really inclusive. It includes many types of partners and many types of services. These are two preferred partnerships with two supercomputer centers. It's only one type of cloud services available. And in all honesty, we're working with other types of cloud providers as well. These two supercomputer centers, why did we take this step? We took the step because we recognized that through economies of scale, the pricing for these types of services is very attractive relative to what a smaller organization, or say if I wanted to equip my own office with this type of equipment, if you go down to the small and mid-scale range, the computational costs go up. So with these large facilities, they have a large enough user base, and they have interesting sources of funding as well. Just as an example, Ohio Supercomputer Center is changing out their complete hardware suite every 24 months, and it's completely paid for by the taxpayers of Ohio. So what's new and different? A PI at UMaine for many, many years or decades could have had access to these systems as an individual PI. What ARC did that's a little bit different is we entered negotiations with these centers from the perspective of the entire faculty community. So essentially, contractual agreements were developed and signed off on that basically gives any faculty member and graduate students at UMaine access to these services all through catalog rates. We're considered a not-a-state nonprofit entity, which relative to many of, the cost of these services for many providers in the state or in the region, this is very attractive pricing. Why did we pick these two? Well, Texas Advanced Computing Center is, I believe, the largest supercomputer center in the US at this time. They've just launched Frontera. That's the 8th largest machine in the world. And it's the fastest supercomputer in academia. I was just catching up on, their press releases here in the last few days. They're also integrally involved with the NSF Exceed program. So OSC is a much smaller entity relative to TACC. So why are we working with them? Well, from my previous employment, I've had a history that goes back to about 2003 with OSC. And in my previous career, I worked with many of the national supercomputer centers in the United States. OSC is not the biggest, but I would describe them as being, if not best in class, they're close to the top. And I couldn't name another center like them that was more responsive. So I know they're very friendly. They treat their customers really well, technical users. And that's why they're here on our slide today. And we haven't seen anything in the last 6 months to make us regret this direction. The storage rates are very attractive. Kevin has done more background research than me in this area, but these are the lowest warm storage rates we've seen nationally. You could look at other service providers like AWS, but if you look at the cost of data transfer in and out of the storage system, all these things add up. Face value is these are the lowest rates available that we're aware of nationally. So the backup data storage service that I mentioned previously, this was done in collaboration with UMaine System IT, with the Advanced Computing Group. The VPR DGS at UMaine made available a little over $60,000 to purchase hardware, and we were able to purchase 225 terabytes working closely with ACG, an existing storage solution, modern, backed up at USM, et cetera, was put online last year. And right now, our main task is making people aware of it. The cost of this backup storage to faculty at UMaine it's free. So, why? Because it's so important that we have the labs with the, small components, disk storage. Some labs are using USB drives. Some labs are using things more sophisticated, but without backup outside of the building or off campus. In collaboration with UMaine System IT, this is available. And if you find yourself in need, please do reach out to us. This slide captures our advisory board. We have a representative from the University of Maine at Machias and also a representative from the University of Maine at Augusta, and the other members are based in Orono. This could change over time. We're happy to bring in other campuses as if other campuses have interest. This board's very important because as we are early in our life, we're setting strategies and making decisions in terms of how we want the types of services that we want to make available. Obviously, the voice of the faculty is very important in setting those strategies. And Ben, thank you for your contributions on this board. I'm getting towards the end of my deck. I think this is maybe the most important slide in the whole deck, and why. I talk with various people at UMaine that have the impression that ARC is largely focused on hardware access. And if you really look at how we've used our time in the last year, it's not, our primary focus is not hardware access. Rather, we find, so many different use cases and roadblocks and barriers. It completely varies by department and by PI and by lab and the combination of students who are involved. So I personally feel that our greatest value add is simply spending time with various labs and understanding the current situation, the current problems, and then, working creatively and talking to other experts in the field, whether they're here at the Orono campus or elsewhere in Maine or out of the state of Maine. So this is just two support use cases to highlight what I'm sharing with you. On the left, it's about RedCap, which is a third-party provider for HIPAA-compliant data storage. Lynn Kay's center on campus was developing a proposal, needed HIPAA-compliant storage, mentioned they'd like to work with RedCap. I'll be honest, I'm not, I wasn't familiar with RedCap at that point in time, but we knew that they were on a deadline for their proposal. So someone from ARC probably spent about a day and a half, gave it priority over other things because the proposal was nearing submission date. And we basically looked out the best options such that the proposal could be completed and submitted on time. And all of that happened, basically we pointed to an existing service, a licensing service available through Vanderbilt, available to academic customers in the United States. So that was built in the proposal. The proposal's awarded. And once it came in, we kind of temporarily paused and thought, is that Vanderbilt solution the best strategy? With input from a variety of people, including the Humane Institute of Medicine, we're now thinking at least we want to temporarily reflect upon the opportunity to host REDCap right at Humane. So Kevin, myself, and one or two other people are working right now looking at this. We're on a short timeline. Kevin is reaching out to other experts at partner institutions around the state, but there's basically 4 paths available to do this, and we're not sure which is best. So our job right now is to articulate the pros and cons of each of the 4 paths and have a proposal available for the internal customers involved in the VPR DGS, hopefully within a few weeks, and a decision will be made. Either Lynn Kay's lab can fall back to the Vanderbilt solution, or there'll be a green light and we'll try to host this at Humane itself. The second example I'm directly involved with because I have dual hats. One of my hats is working with EPSCoR, and the second case deals with the Maine Indian Day Track 1 grant that's underway right now, led by Humane, but statewide, 10 or so partners. But the researchers on the Maine Indian Day grant requested support to implement a bioinformatics data management system, and MyTardis was identified by the team as the preferred solution. MyTardis is open source software based out of Australia. So we've actually been working with this for a few months now, and we started small scale on a local server, installing it, testing it, giving people on the Track 1 grant access to really look for optimal configurations. And once we had some knowledge gain, we ported the solution to a third-party cloud provider called DigitalOcean. And we knew DigitalOcean worked well with the software. That's where our solution is currently sitting. And we continue to expose access to more and more people on the grant, and basically we're kick testing it before it goes grant wide. So Ben's vision is this solution will basically be used to share the data that we're taking on the grant. It's environmental DNA type data, and processing will be done so the raw data and the process data can be shared statewide and theoretically outside of the state as well, although there's other solutions that we're looking at too, including federal solutions for national access. This is the type of work we spend most of our time on, in short. It's not, helping somebody like Ben buy a local storage device for his lab, but it's rather looking at solutions like this. So in some ways, we're more of a technical support or services type group than a hardware provider. To give you an idea of who we've worked with in the last, this is probably reflective of the last 6 months. We're typically working with an individual faculty member rather than the director of a center, but we keep track of, if we're working with a faculty member, who are they contacting us? Who are they working for? And those interactions tie back to these initiatives and centers across the UMaine campus. So it's pretty good coverage, even though we're early in life. We like, this, I see this as healthy progress, and we'll see where this year takes us. The top 3 are probably where most of our engagements are occurring, in fairness. The Track 1 is definitely on top. UMaine AI initiative being led by Dr. Ali Abedi. We've had quite a bit of interaction with various faculty who are doing machine learning work and artificial intelligence. That's a big national initiative. Every national meeting I attended, including today and yesterday, half the discussion is around AI. And the New Institute of Medicine, of course, is very important and overlapping with the AI initiative. So that's a very brief summary of advanced research computing, our origins, what we've been up to, and what we're hoping to achieve. And next, I'd like to introduce Kevin Wentworth, and he has a separate slide deck. So we're just going to take a second and switch over.
Good afternoon, everyone. My name is Kevin Wentworth. I'm the Manager of Research Information Management and Computing Systems at UMaine underneath the Office of the VP of Research. As Shane mentioned, I am responsible for reaching out and establishing external partnerships for the benefit of UMaine researchers. And today I am going to start my slide deck for us here. And now I will go to the next slide. I'm going to focus on OSC. As Shane mentioned, we've partnered with TAC, Texas Advanced Computing Center, and OSC, the Ohio Supercomputer Center. Focusing on OSC today because they have a really neat product that I'm going to demo later. So just a little bit, touch on a few points. There's over 22 staff members at OSC that are willing and ready to help. They have excellent customer support, and this partnership between an out-of-state university with OSC is unique, and they're just as excited about it as we are. One of the most incredible benefits is that we get priority in the queue system. We're paying for access, so our jobs run first. I know that is great news to many of you listening. So basically, it's a pretty simple process. You work with ARC, and we will get you access onto the system. Then once you're on the system, any technical support or troubleshooting that you may have, you can reach out to OSC. There's sort of an infrastructure in place to support things at the project level. This is great because if you write funding into a proposal and get funded, you're going to have a particular budget in mind. And on our side, on the UMaine and the ARC side, we're going to make sure that all of your usage is charged to the appropriate chart field. And then for your benefit as a PI or as a researcher, you can see your usage. You can do budgeting through the portal. You can add and remove users and groups so that you can share Unix file permissions. And it's basically a nice web-based project management tool. I have a couple screenshots here. I didn't want to demo this part of it, but on the background, you can see the project dashboard. When you first log in, you'll see sort of the usage by project and by the cluster. Just a nice dashboard snapshot. You can have as many projects as it makes sense. Again, we tend to recommend setting them up by, funding sources or by lab, or there's really a lot of flexibility. But as you can see on the pop out, the managing of the project users, you can see the current members, you can invite new members, you can assign administrative roles through this, this My OSC dashboard, so people can help support in the role of project management. And then as you get deeper into the actual projects, you can see a line by line, job by job HPC activity. This is great. You can see the pricing, the core hours, memory, all sorts of information. What else is great is if you click on the View Add Note button, a pop-up comes up where you can communicate either to OSC or to the PI, what might this job be? So if you want to take notes or, justify why this took a long time, or, it's a great communication tool to keep your project on track and sort of have a single source of information about, your activity. So I'm going to get into Open on Demand. This is pretty interesting. It's a couple years old. Basically, the original, it's an NSF funded project. It's currently in its second award, and it's a piece of software that a system administrator would install to give their users access to their cluster. So I'm not going to focus on that element of it today. I'm going to actually focus on being a user and using it, but it's pretty amazing. HPC, and by that, I mean high performance computing, is one of these industries that has been late to adopt this concept of, an app. You can do everything on an app on your phone except HPC or in a mobile browser, but that's not the case anymore. The last few years, this open on demand product has allowed pretty much anybody with a web browser to get onto the cluster. Here's a bunch of people that are actually have on demand in production, just to give you an idea of the support. And now this is sort of my agenda for what I'm going to show you today. So OSC on demand is what OSC calls their on demand product. That's not to be confused with the open on demand, which is their community open source software package. So at OSC, they've installed a version of on demand, and I'm going to show you how to use the file manager, how to see the job manager, and show you how easy it is to actually start up an interactive session. So bear with me while I get out of here and magically log in to the OSC on demand portal. So there is a bunch of statistics and stuff. You can see I'm 25% of my jobs are inefficient because I've been playing around for this demo. But let me get right into it. I'm going to go into the home directory, and this is their file browser. I'm hoping that I'll start with the stuff that might not be as exciting and finish with a grand finale. So pretty easy, double click. You can move around. Nothing too fancy here, but what's nice is if you have a whole folder, if you have a whole folder of stuff that you want to upload, you can just go ahead and drag and drop that into this interface, and it's going to upload all the files, maintain the folder structure, everything, which is great. Now I can, actually edit this file in here if I wanted to, save the changes. This is all going on within a browser, which is just, pretty incredible. I can also, download these files and, of course, delete them. So this is the recommended way to get, files up to their cluster if they're under 2 gigabytes. For larger files, you're going to want to use the traditional, FTP methods or something else. Great little thing to point out is this open in terminal button. I'm going to click that, and it's going to open a new tab, and I am now in shell, in the command prompt or the shell for the Owens cluster. I'm actually in the, I'm in the exact spot where I clicked open in terminal. I don't have to go hunting around. I can show you that, there I am. I'm in the on-demand folder. I can do any command that I would be able to do on their cluster, over SSH right from the browser. No special plugins required. It's just, blows my mind. So hopefully you see the benefit in it as well. This is the manual for the slurm batch command. And then I'm just going to close that connection, close my tab, and back at the file manager. So back to on demand. You can schedule new jobs right from here. If you can select from templates, you can create your own templates. I'm just going to quickly show you that this is sort of the GUI version of scheduling jobs. If you had active jobs going on, you could come back and actually see the active jobs running. You can't see the history of the jobs here. That's going to be in the My OSC portal, which I'm not going to show today, but here's the active jobs, which there are none right now. So now that I did want to point out this system status in case you wanted to see, how long it might take you, how long you're going to possibly wait in the queue. This is a live version of, exactly what's going on their 2 clusters. So you can see the queues and what's running. It's nice they separate out how many queued jobs are actually requesting the GPU. the GPUs are obviously you know, under high demand. So can click on an actual you know, cluster and see even more details. So I don't want to get too in depth here, but quite a bit of information. So now onto the interactive apps. I was going to start with Jupyter Notebooks and you know, Apache Spark. So you can select, if you're on more than one project, you can select which project you want to sort of you know, account this usage to. You can choose how many hours and how many nodes you're going to want. In this case, I'm going to leave it 1 and 1 so I can hopefully get right on there. You will go in the normal queue, and you'll see that in a second. But I'm going to do this tutorial just for the sake of this demo, and I'm going to click launch. And now it takes me to this screen where it says my session is currently starting. So this is live on the server. I'm half expecting it to not start up immediately because I'm finally doing this for the presentation. But you know, earlier today it would only take a few seconds. So now my job was queued up, and now it's actually running. You can see my job is running up there. So I'm going to open the tutorials folder. And I'm following a tutorial that they had provided, but so I'm going to open up this this copy that I did yesterday. And as you see, I'm still in the browser, but I'm actually, you know, I'm on there. I don't know how they do it, but anyway, I'm on there. I'm on the cluster in the browser. This is incredible. So I'm going to scroll down. And I'm just going to do something, you know, this is just the tutorials teaching you how to do, you know, Python and Jupyter Notebooks. I'm going to hit the run, and I'm not sure if anything interesting is going to happen here. You know, it's, I may have to just go back and start the tutorial. Oh, you know, I'm waiting. So there we go. See the results are popping up right underneath the inputs. So what I'm doing is I'm putting my cursor in here. This is where you could type in, you know, the actual commands that you want to run, and then you can click run, and you know, the results will be shown below. So anyone who's familiar with Jupyter Notebooks, you know, this should look pretty familiar to you. I'm going to now, you know, I'm going to log out of that. Okay, and I'll close out of here. So now I'm back to OSC on demand. I'm going to refresh the browser. You can see that my job is still running. So I requested an hour, so I still have 57 minutes left. If I wanted to get back in here, and you know, I've sort of reserved that time until my that hour is up. So I could click here and go back into there, start another tutorial or whatever. I'm just going to show you that if I go back to the active jobs now, and give this a minute to update, there's my active job coming up right there. I can come back here. I can get more information than you know, than I could possibly want about the job. And I'm going to switch back. Hopefully no one's getting motion sickness keeping up, but I'm now going to just delete this job. And now that job is done. So I can come back and choose something else if I wanted. I'm going to point out MATLAB. What's nice about this is we can use the license that MATLAB has at OSC as long as we're doing academic research. You do have to request that, but I wanted to point out that that's great news that MATLAB is available, and we don't need to deal with licensing it for UMains purposes as long as we're doing academic research. So I'm going to launch MATLAB. Now this is MATLAB has a GPU component to it, and so this one's probably going to take a little while to launch. If it takes, oh, look at that. So I'm going to launch MATLAB. And this is using, Open VNC, I believe it's called, to sort of, or it looks like Turbo VNC. But anyway, I'm inside of a virtual, desktop to the server, looking at MATLAB. And if I knew MATLAB, I could go to town here, coding up whatever I'd like with the full power of OSC supercomputers behind it. So it's pretty amazing to be able to just come in your browser, start up a job, and that's basically all it takes. So that's the end of my demo, and I will stop sharing my screen, and I'm going to turn it over to Ben King.
Great, thanks, Kevin. And good afternoon, everyone. I'll start up my slides here. So I wanted to give you a perspective from a user's point of view about using the resources from ARC, and specifically in the scientific area of genomics. And so I'll talk a little bit about cloud computing a little bit with respect to genomics, and then give you a taste of some of the ways that my lab has used the resources to look at gene expression using RNA sequencing, annotating microRNAs, which are non-coding RNAs, also metabarcoding data analysis, and calling sequence variants. So a lot of this work has been done by graduate students in my lab, so it's not where I've done all of these things. So I definitely appreciate their help. And so with cloud computing, this is something that is certainly recognized by the National Institutes of Health, which does fund research in my lab and other labs here at the University of Maine. And a few years ago now, they did come up with a strategic plan for data science, and recognizing clearly that the cloud is the future, right? It's a way of that you can spin up different servers that really scale with the data that you have. So it's an efficient way of using high performance computing resources. And the NIH has many different initiatives, but one of them being the STRIDES initiative, and there are others. And in terms of other efforts in genomics, certainly the NIH has several, including Anvil and Terra and others at different NIH institutes. But the National Science Foundation, of course, has Sciverse as well as Exceed. And some of you may have used Exceed resources in the past, but a number of ways of using different cloud-based resources. And then from the commercial side, of course, we have the major providers out there, AWS, Google, and Microsoft. But indeed, they've also launched various initiatives about genomics, and actually making those genomic tools integrated into their cloud computing resources. And so this is something where there's a lot of economy of scale, just because sometimes the data sets can get extremely large. When using a cluster, I wanted to talk a little bit about, again, from the user's perspective, how you might use a Linux cluster. And if you've not done this before, the way that a cluster is organized is that there is a series of networked computers, essentially, these compute nodes. And there can be hundreds of them or thousands of them that are all networked together in one particular cluster. Then there's something called a head node, which is actually how you interface and log into the head node of the cluster to run your jobs. And the important steps in using a Linux cluster, of course, is uploading the data to the cluster, in interacting with those data on the head node. You also need to install software. And sometimes there's software that's installed on the cluster, which is great, but sometimes you need to end up installing that software in your home directory. And there's also a technology that's called containers that I'll explain. Then you have to prepare a script to actually run the software. And so those scripts will load the software on the compute nodes and actually execute the software. And there are different parameters that one needs to set. So there's a concept of a queue, which is the list of jobs. And you can configure which queue you're using, which is a series of nodes that you, perhaps they feature a particular architecture, like having lots of RAM on a particular node, or GPUs or whatever. And then you specify the number of compute nodes you want to use and the maximum runtime. And you write these scripts using in a syntax that's compatible with the Slurm network workload managers system. And that's something that's used not only at TAC, but also OSC. Then you're running you submit your script to this the queue and download the results. So using a Linux cluster is, really consists of these steps. And there are some really fantastic clusters. So at TAC, been primarily using the Stampede 2 cluster, which is a very, very large cluster, and certainly amazing statistics on its performance. And then there are 2 clusters at OSC, and Kevin showed you how to interface with OSC. But these are clusters that you can have access through Arc. And obviously these, some are larger than others, like the Stampede cluster, and it really depends on your needs. So once you have access to a cluster, there'll be some analysis workflow that you want to actually execute. So this is a workflow. Caleb Barton in my lab made this diagram. So for what we call reference-based RNA-seq analysis workflow, and using this, we can look at gene expression, say in the zebrafish, in response to something like influenza A infection. And then by analyzing the data, look at differentially expressed genes. And so one would want to run each step, as shown in these blue boxes. And so one needs to have the software installed on this Linux cluster. And you can look at all of the software that's installed using a command called module, and look at what's available. And some of the ones I've highlighted are ones that we commonly use. If the software is not accessible on the cluster, then you can install that software in your home directory, or load the software using containers. And wanted to mention with the Stampede 2 cluster, there's a really useful user guide that's accessible online, and for an advanced user really is a fantastic resource. And if you're new to this, certainly reaching out to Kevin at Arc is a really, really helpful to have someone that can help you learn how to use these tools. So once you have the software installed, then you would write a script to actually execute the software. So this is the first step in this process, is trimming adapters and low quality reads with software called Trim-O-Matic in this particular workflow. And so one writes a Slurm script where you're declaring what queue you want to use, how many processors per node, what's the maximum runtime you want to use, other details about the job. And so this SBatch syntax is specific to Slurm, which is the job scheduling software that's used on the cluster. And then finally, the actual command to execute the Trim-O-Matic script. And so one has to make these scripts in some way. These are just text files, but once you have them, then you would submit the job to the cluster using a command like SBatch, and that job will be submitted and given a job number. And you can monitor that job being run on the cluster. And yesterday when I was working on these slides, there were over 2,400 different jobs running on the cluster Stampede 2 at the same time. So there's tremendous capacity. I didn't have to wait for, there were plenty of nodes left over for me to use for this particular job. Another way to make software easy to install on a cluster is using a technology that commonly called containers. And it makes it easy to install software because the software itself may have lots of dependencies, and you can think of it like a series of dominoes. In order for one or a house of cards for that matter, everything is built one on top of another. So there are lots of dependencies, and one has to have sometimes a lot of different underlying software dependencies installed before you can successfully install a software package like QIIME 2 that I'll talk about later. And with containers, it makes it easy because all of the applications, including the dependencies, are essentially wrapped up together in a container. And using technology like Docker or Singularity, one can load a container, and then that software becomes something that you can execute. With Singularity, you can also include data with containers, and makes it just very easy and seamless to run. And another nice aspect of containers is that it makes your work reproducible, because you can store a Docker container or Singularity container, archive it, and whenever you need to, load that container up again, and you have that analysis environment exactly how it was before. QIIME 2 is an analysis workflow that's used with metagenomic data, something we're using with the main eDNA EPSCoR track 1 project. And so this is where we're reading in sequence files and determining different amplicon sequence variants, and then annotating those sequence variants. And there's a series of steps. Each step, the way that we've implemented it currently, is a separate script. One could have all of the commands for the entire pipeline all together in one script. But what I wanted to bring your attention to is, with this line here, Singularity pull Docker, I am obtaining a copy of the Docker container for QIIME 2. And then once that is pulled, then I'm running that. And using Singularity, one can run Docker containers. And this makes it very easy to have QIIME working. I didn't have to ask a system administrator to install these packages. I'm doing it all just using the containers. And once you have that, there are different commands and different arguments that are used to run QIIME, and that's what's being passed here. So Docker containers are really, really useful, and using them with Singularity makes it very, very easy. Other workflows are like calling sequence variants. Again, Kayla's been working on this, where we have a reference genome, and then sequence data from different individuals of this particular species, and we're trying to determine whether there's sequence variation near different loci and in the genome. So it becomes very easy to do this analysis. We have to create an index for the genome that we're searching. We do this just once, and this can be a slightly time-consuming step, 46 minutes or so. But once you do that, then you can run this workflow on one node for one sample, use a different node for a different sample. And if you add 100 samples, you could use 100 different nodes. And with these very large clusters, it makes it very easy. You're launching all of those jobs, submitting them to the queue all in parallel. So essentially the runtime that it takes to run one sample, you can run maybe 100 samples as long as there are nodes accessible. So there's an economy of scale in that way. So what I've tried to do is to give you a sense of some of the high throughput sequence analysis workflows that we've implemented for RNA-seq, metagenomics, and calling sequence variants. And there is time that one has to invest to learn how to use a Linux cluster. But with the help from ARC, with Kevin in particular, one can figure out how to run things, especially if you don't have done this before. It's something where there is support, and that support is really, really valuable. You can't just read documentation alone and figure out how to do all of these steps. So the user documentation is certainly quite helpful, but it sometimes takes an expert's eye to understand completely the user documentation. Certainly it is easy to run different containers using Singularity, both at OSC and on Stampede 2 at TAC. And certainly lots and lots of capacity in terms of having lots of nodes. So again, having the technical support through ARC is really, really important. So I very much appreciate the support. So wanted to acknowledge folks in my lab, as well as the folks at ARC and different funding sources, and especially the main EPSCoR office, who's arranged for allocations for that project at these resources. So certainly appreciate all of that help. So I think I'll hand it back to Shane.
Thank you, Ben. So that completes the first 3 phases of the webinar today, and we have at least a little bit of time for questions. Actually, we have more than a little bit of time for questions. And I have a few myself that I'd like to ask after just seeing your presentation today and your delivery of your presentation for the first time. But maybe I'll get started here, and any audience members that like to submit a question, please use the Q&A panel, and we'll be monitoring that as well. So Ben, you're very unique in terms of the labs who we have worked with, in that you've had your students involved right from the beginning, is my memory. And I'm not sure if I'm remembering 1 or 2 students, because you've worked at both OSC and TAC.
Right.
But I'm just curious as to, graduate student participation using these supercomputer centers. Has that been a difficulty? What are the steps you're taking to make sure the student can be successful?
Yeah, they've certainly taken a lot of self-initiative to just have the confidence to dive in. And certainly I gave them some template scripts to get started with and things. One thing that is helpful when working as part of a team is sharing data. So we did learn how to set up groups so that we could share data amongst ourselves in the lab, and so that's something that's doable and is very helpful, because one can look at say the error log files that are generated when something doesn't work, and that's really, really important, is to have that accessible to one another.
Okay, thank you.
Yeah.
Now, you've been involved with ARC really from the beginning. I mean, we were speaking with you before we had these formal agreements set up with TAC or OSC, and you described to us features and attributes you thought were important. I remember back at the beginning, TAC offered container support and OSC didn't. At least that's how I'm recalling it today. But OSC more recently has introduced containers, and I'm curious, if you had an infinite supply of time on both of these providers, do you have a strong preference in terms of the work that you're conducting, your lab is conducting? And if so, why?
Yeah, containers are really important. Yeah, it's not that they didn't necessarily support them, but at TAC, what they had, and we had learned about actually through working with Kevin, is that they had the Singularity technology installed on Stampede 2, and that allows you to use any Docker. There are literally thousands of containers out there that one can access with different workflows. And one thing that I hope to do through a collaboration with the main INBRI program and the NIH, is to make a series of containers that are specific to some of the workflows that I feature in different courses. There's certainly others that have been developed for bioinformatics, but one thing that's challenging when working with in different courses and teaching people is that you can provide during the course really, really nice environments for people to do their work. But when they go back home, to replicate that environment can be quite difficult, and containers really are the solution to that. So they can load a container and then have the exact same analysis environment as they do their work.
Do you find, the follow-up to that is, do you find that both of these centers right now are comparable in terms of your technical requirements? Or is there still, in terms of your specific use case, are you leaning more in one direction than the other?
At this point, I view them as pretty equal. Just the size of Stampede 2 is very, very large and hard to get one's mind around. But I think as long as it does come down to queue times and that kind of thing, as well as the support. So I think they're both good options. And I want to say it's somewhat agnostic as to which I favor.
Well, that's good, because I'm not sure that you started that way 6 months ago. So that's
yeah.
not.
So yeah, and one thing to mention though is that TAC, is one of the largest supercomputer centers in the world, right? So there are some compute tasks that can only be done on enormously large infrastructure, and so it's nice to have contacts at a major resource like that. So I think that it would be nice to keep that door open, in the future, because I could see some faculty may have needs for extremely large, compute needs.
It's our intent to keep the door open for sure.
Yeah.
So a third question I have, and I don't see any Q&A questions yet, so I'm going to keep talking. But you've spent more time working on both of these centers, and I guess there's one or two other faculty perhaps that are comparable. My memory is your team has perhaps interacted more with technical support at these centers than others that I can think of right now. In your presentation, you talked about support from ARC, and in very complimentary terms, and I'm happy to hear that. But the dedicated technical experts at these centers are very important also. In terms of your team's interactions with the support staff through their support vehicles, can you summarize your experiences? Have they been reasonably okay, or
Yeah, I think they've been good. Like with anything, having people that you can meet with in a non-pandemic world is helpful, right? I remember going to meetings with Kevin and things. So sometimes having that face-to-face contact is important. But with the help desk, certainly, there are things that come up, like filling your disk allocation, other things where you might trigger things where really a system administrator needs to go back in and unlock your account or what have you. So there are always things where you need to have that support. But often, getting started, it might be intimidating, right, to reach out to a help desk to ask, well, can you help me write my first Slurm script, right? And in there, it's certainly better to meet with someone like Kevin. But so always having that kind of support is important, and yeah.
Okay, well, that exhausts the questions that came to my mind through your presentation. And I don't see any posted questions beyond what I've asked right there. Just give me one more second to check. I guess the only other question that I'm seeing here is why are there two supercomputer centers that we're working with? Where, you know, there's quite a few in the United States from East Coast to West Coast. So Kevin actually was very involved with the initial surveying we did. This goes back about a year. So I'm obviously a proponent of OSC because I have almost 20 years of history with them. TAC I'd never worked with, to be honest, but it was clear that they're one of the largest in the country, if not the largest. They're 8th in the world right now from their own data. So we kind of gravitated in that direction after engaging and speaking with TAC, but there are a few other attractive centers. So why aren't we already working with them? Well, we'll let the customer needs drive those discussions. If we work with a lab or department on campus and, you know, TAC and OSC are not suitable for the use cases at hand, you know, it's a bowl of cherries and we can go in multiple directions. Now that we have these umbrella agreements were new to these organizations. This UMaine's request was not a standard request in recent years, but now that we have this track record with these two centers, I'm confident that we can be successful with other centers in the country. So why don't I pause there? Any closing comments from the panelists? Kevin, Ben?
Look forward to working with everybody at, you know, expanding HPC across, you know, UMaine and the UMaine system.
Okay, well, I thank the panelists and I thank everyone who attended today and for allowing us to record. So we'll probably break this into smaller pieces and make them available through the ARC website. Thanks very much, everybody.